Hi, this is Eric. Today we're going to do a quick problem on convolution. So suppose you have an LTI system with the impulse response h of n given by this, and you input into that system x of n, which is given by this. What's the output y of n? So to get the output y of n, you do perform convolution. Now, before performing the convolution, we should be able to get the length of the output just by looking at the length of the input and the length of the impulse response. So it turns out the length of the output y of n is going to be the length of the input 2 plus the length of the impulse response 3 minus 1. So the length of the output is going to be 4. And we can go ahead and confirm that after we do the problem. So let's do a quick block diagram just so we can see exactly what's going on. Here's your LTI system. It has an impulse response, h of n, and we're going to input into the system x of n, and we're going to attain an output y of n. All right, easy enough. And we know that the output is going to be the input convoluted with the impulse response. Now, convolution is commutative, so we can do impulse response convoluted with the input, and we'll get the same thing. So, let's go ahead and do this problem. Y of n equals input convoluted with the impulse response All right, so delta of n minus 1 convoluted with the delta function delta of n minus 1 convoluted with 2 times delta of n minus 1. Well, that's going to be a delta, which is going to be a 2 times delta n minus 2. Delta of n minus 1 convoluted with 3 times delta of n minus 2. Well, that's going to be a 3 delta n minus 3. Now, we're going to keep going. It's going to be a 2 delta minus 3. And finally, it's going to be a plus a 3 delta and minus 4. All right, let's go ahead and simplify. Okay, here's our final answer, y of n. And we can see that the length of this is in fact 4. 1, 2, 3, 4. All right, this was a pretty quick video on how to do convolution. Thank you.